All right, here we go. We are going to be graphing quadratics. This is going to cover 9.1 and 9.2. We're going to do it all in one. They divide it up, but I think it's easier if I show you how to do it in general, and then it applies to everything rather than showing you certain scenarios and certain ways to graph. I'd rather do it kind of like with factoring. I'd rather show you one way that always works than show you certain ways and you have to remember which works with what. All right, so first of all, you need to know what a quadratic looks like when it's graphed. Okay, and you may have seen this, and there's a picture of this on your notes. But when we graph a quadratic, first of all, what is a quadratic?
Something that has four things.
Ooh, you'd think, right? A quadratic, that's right. A quadratic is what we have been factoring. It's the ax squared plus bx plus c. The exponent of 2 is what makes it a quadratic. Okay? And so we've done a lot. We've taken the two parentheses, we've multiplied them out to get a quadratic, and we've taken the quadratic and factored it to get the two pieces. That's what we tested on yesterday, right? So now we're going to graph them. That was right. You can say yes, that was right, because I was right. Y'all are a tough crowd today. Okay. I said, when we did that, we got a quadratic, right? And I said, yeah. I know, because I said, when you factor it or when you FOIL it, you're working with a quadratic, right? Yeah. All right. My goodness. When we graph quadratics, we end up with what we call a parabola. This is called a parabola. It can open up or it can open down. Okay? It can be skinny, it can be wide, it can be up here on the graph, it can be down low on the graph, okay? But in general, this is what it looks like. So I need to talk about some key parts of parabolas so that as we start graphing, you'll know what I'm talking about, okay? It can go up or down. It's the same thing. This number in front, the A, if it's positive, this is when A is positive, it opens up. When A is negative, it opens down. So you ask what makes it open up or down? That A in front makes it open up or down. Probably the most or one of the most important parts of the parabola is this point right here. Does anybody know what it's called? It's called a vertex. And here's why it's so important. You're absolutely right, Kennedy. There is one point that is absolutely the lowest point on the entire graph or the absolute highest point on the graph, depending on which way it opens, and that is, in fact, the vertex, okay? Thinking geometrically, okay, what do you notice about a parabola? It's shaped like a U. What's special about a U like that? Think in terms of shapes. What about either side, Shaija? They're the same. What do you call a shape that is the same on either side? It starts with an S. Symmetric. That's right. It's symmetric, okay? And because it's symmetric, if you drew a line straight through the vertex, it's like holding a mirror up because it's exactly the same on either side. It's a dashed line. That dashed line through the vertex is called the axis of symmetry because it cuts your parabola in half. I need to tell you about the quadratic before we start graphing. You know how I told you the A, what does the A do to the graph? Negative, positive. And if it's positive, what does the graph look like? It's happy it opens up, right? If it's negative, that's right. It's sad, it's frowning, it's upside down, okay? The other thing that you can draw from this equation, so we've got an A, a B, and a C, right? The C is very special, okay? The C, I'm glad you asked, Samoria. The C is very special because it is, you know how when we're graphing lines and we have mx plus b, and that b on the end is real special? The C is the same thing. The C is the y-intercept. What is a y-intercept? What does that mean to be a y-intercept? Where it touches the y-axis. That's exactly right. It's where it crosses the y-axis is a point on the y-axis, okay? The B, we're going to use it to find the vertex. Okay? When we actually put these on the graph, y'all got all this? Let's say this is my parabola, right? And here is my vertex. What is this line called? That's right, the axis of symmetry. And I know it's the axis of symmetry because it goes through the what? The vertex, okay? Here, that is my y-intercept, right? Because this is the x-axis, this is the y-axis. So the x-intercept, which one gives me the the y-intercept? C. So that's C from your equation. There's two other special points on here. They are these. What are those called? If this is the y-intercept, what are these? Are x-intercepts. And they have multiple names that you need to be able to recognize to know that if we say this, we're just talking about x-intercepts. I think they're listed on here. Yeah. They're also called zeros or roots or solutions. The first two are the most common. All right. Y'all ready to graph? Oh, one more thing. This is not on your sheet, but I do want you to write this. If you have an equation, and we've talked about this some as we factor, what happens if this is missing? It's a 0, right? If it's missing, make it be 0. Same with C. Because what we're going to do is we're going to use a little formula to find our vertex, and if it's not there, you need to know what to plug in for it. B would be 0, so this term would be 0x, yeah. All right, flip it over. There's an example at the right. There are steps on the left. Okay? We're going to fill this in as we go. This has already been filled in for you, so if you just want to watch as we go and talk to me and help me as we go, then you have this in your notes, and then we'll do several together. Okay? Okay, Miss McGee. Okay. Okay. All right. My equation is y equals negative 2x squared plus 1. Now, before we even graph, tell me some things you know. We know B is missing. So B is 0. Okay. What else do you know looking at that? Negative 2, which tells me what? Sad parabola, right? In the front, see the negative in front of the 2 in the front? Oh, I see it right here. Yeah, on the right, yeah. You good? Okay. All right, so you've already told me we know B is 0. We know it's sad because it's negative, so it's going to go down. One other thing to know from just looking at that equation. Y'all can do this. What is it? What else do you know? The y-intercept. Good job, Joe. The y-intercept is Because the C is the y-intercept. So it's going to cross, I know it's going to cross the y-axis at 1, right? A is -2. So, well, okay, so let's list them because step 1 says to list out A, B, and C. So if I look at this equation, A is what? 0. It's going to be part of it, but we're going to have to use it to find. All right. Uh-oh. Yeah, fix that. It should be +1. Sorry. Okay. On your step sheet, it says C is -1, but it should be +1. All right. Here's where you're going to have to do a little bit of work. Y'all ready? We have to find the vertex. Remember that vertex is very important. That's the center of the graph. So that's what I need to find first. So several of you have said, well, how do you find the vertex? Well, there's a little equation to find the vertex. Now, if you think about this, I'm going to go back just a second. Any vertex is a point, right? This is a point. And a point has an X and a Y, right? So there's two parts to every point on this graph. There's an X part and there's a Y part. So let's say I've got this equation. Let's say I have an X. How would I find the Y? What do you do? If I told you what's the Y when X is 5, what would you do? Somebody knows this. Come on. Yes, plug it in. If you know X, then to find the Y that goes with that X, you'd plug it in, right? Okay. I just wanted to make sure, and I wanted you to understand that the vertex has two parts, an X and a Y. Because if you look on your sheet, it says to find the vertex. Okay? The vertex, there's a little formula. It says X equals -b over 2a. Now I want you to make a little note on here because I don't want you to think -b. I want you to think opposite b. Here's why. If b is negative in your equation, then you would make it positive when you plug in here. It's opposite b, not negative b. Because two negatives would make a positive, right? So instead of thinking, sometimes if you say -b, it makes you think that it's always negative, but that's not always true. So it's easier to think opposite b, okay? So I want you to look at your equation. You've got A, you've got B, and you've got C. If we plug in this little vertex equation, then X equals opposite B. You don't really have an opposite of 0, right? It's just 0. Over 2 times, what is A? -2. All right, look at your equation. This is your equation. You can't, so you just keep it 0. Yes. Then it would become positive. We're going to do several like that are that way, too. You don't understand what we just did? No. All right, tell me where I lost you. Okay, do you understand that the equation is just something I'm giving you? The -b over 2a, that is just something I'm telling you. That is how you find the vertex. It's a formula. Every single quadratic ever, to find the vertex, you do opposite b over 2a. Every single time. It doesn't matter what quadratic you're graphing.
So like, when you do that, like you do
Yeah. Okay. So now if you look, all I'm doing is I'm taking where up here, come on, up here where I had A, B, and C, B is 0, so it goes up top. 2, 2. A is -2. I just plugged in. The 2 is part of the original equation. It's 2 times a.
So you always start with 2.
Every time. Always times it by 2. Okay? No, I'm glad y'all are asking questions because when you ask the questions, it helps you understand. Don't be ashamed to ask questions. All right. 0 divided by anything is 0. All right, take a look at what I got. I have the x part of my vertex. Now, I want you to make a note on your step sheet that this is your axis of symmetry at 0. Up and down at 0. That's your axis of symmetry. So the equation for the vertex and the equation for the axis of symmetry are exactly the same. Okay? All right. Sorry, Mario. All right. Now look, because here comes the part where you have to think through. It says to make an XY chart, you need 5 points. Okay? The middle point, so I need 2 points, 1 and 2, and then I need my vertex, and then I need 2 more. Okay? So you're going to go 2 up, 2 down from your vertex. In this case, it's 0. That makes it easy. If it was 5, then I'd go 4, 3, and I'd go 6, 7. Okay? 2 up, 2 down from wherever that vertex is. 2. All right, so your vertex, 0, you're going to go 2 up and 2 down. If it was another number, like let's say whenever I did it, that my vertex was 5, right? Let's say that was a 5. Then I'd need to go 2 up from that and 2 down from that. Okay? The vertex needs to be the middle, and you need points on both sides. 2 up, 2 down. Okay? So in this case, yep, -1, -2, 1, and 2. Yes.
So when you find y, you have to roll over and on.
That's going to be the most work. Yep.
So you got to plug it in with
Yep. Now, several of you have already figured out that for each one of these x's, we have to find the y that goes with it. Remember, Zamoria, when we have a point, it has 2 parts. It has an x and it has a y. To find the y, we plug in, right? So for this one, y equals, I'm starting with a -2 because it's just the first one on there. All right. The -2 is outside, and then I'm doing -2 squared plus 1.
Where does square come from? I got to put
All right, look, you need to see where I'm getting this, guys. I need you with me here, okay? This is the work part of it. I'm putting in, I'm taking the original equation, okay? That's okay. Yeah, they're right there. All right, exponents come first. -2 squared is 4, right? So I got -2 times 4 plus 1.
Okay, Byron, you did all that right there. Oh, they did 0.
That's right, so that I could go 2 up, 2 down.
Oh, okay.
Okay? What is -2 times 4? -8. And -8 plus 1 is?
It's not that bad.
It's a lot of work. It is a lot of work.
It is, but I get it.
I'll probably get messed up on like that.
So do we have to graph it too? What?
That's the whole point. But the graphing's easy once you get the T-chart.
All right, so.
All right, stay with me. Stay with me. I'm listening. Which next part? I use this equation because this tells me what y is if I have x. Always use the original one. Yep, you're always going back to that one. 2, that's exactly right. That's right.
So what that?
This is where I use this equation, and I plug -2 in for x.
Okay, well, so confused with it. -2 square plus 1.
Because you do exponents first. -2 squared is 4.
What? I'm not about to write that. I know it's not.
Now look, when I plug in -1, I square first. -1 to the second power is what? 1. -2 plus 1 is -1.
And that's what formula is -1.
Watch, look. Take this original equation. -2, -1
So why you gonna say
squared plus 1.
I was thinking about doing that.
You think paper calculators on
Why would they pay you like $2 a month?
Because we're sharing that between 2 different classes.
She need to get her own.
All right. Now, let's do the 0. Let's do the 0. See if you can get this on yours. See if you get it. Plug in 0. And 0 special, why is 0 special? Why else is it special? It's the axis of symmetry. The vertex is going to lie on the axis of symmetry.
Why they first one and the last one the same? 1. We should get 1, right?
You should get yes.
Okay.
Now try 1. What do you get? She get -1 for that one. You did +2 plus 1 instead of -2 plus 1.
Then the next one is -7.
That's exactly right.
Now y'all know that.
And now you just gotta.
And that it makes sense when we graph it. You'll see. Remember we talked about it being symmetric. It's the same on either side. Well, yes, as long as the axis of symmetry is 0.
So if we take the
But when we move that axis of symmetry, then it starts getting a little wonky. But yes, you're exactly right. If your axis of symmetry is 0, you really only have to find those 2 and just do the same thing from the other side. It makes it easy. All right. Let's graph it. Y'all ready? Yeah.
No, can we use the calculator?
We haven't, y'all, we haven't even started. Come on here.
Can we use the calculator?
All right.
Are we gonna use calculator?
Have I ever made you take a test and not given you the calculator?
Yeah, someone's definitely used to that one before.
Then that was of your own volition. Okay. Look. -2, -7. -2. 1, 2, 3, 4, 5, 6, 7.
I'm talking about homework and we don't know exactly. And that's instant.
-1, -1, -1, -1.
It's probably another part.
0, 1.
We can do this, you guys. I have to
1, -1. And 2. Remember, this one's on your paper for you already graphed. All right, now look, when you do this, it's not a V, okay? A parabola doesn't do this. Okay, you have to curve this top out around, okay? So, let's connect it.
I was definitely the dog. And I just had to do two.
Does that make sense?
Yeah.
All right. I've tried to go super duper slow through it, so you see. So it won't take that long every single time, but I wanted to really creep through it to help you. Flip over. For number one on the graphing quadratics, the axis of symmetry is 0. So I'm gonna skip over that one because I'm gonna do one more with you. Let's do number 2 because those numbers get pretty big.
That's it, literally.
That's it.
No, let's do number 3 again.
This one was a negative. For number 3, you might want to make a note. A is -1 because it's just a negative in front. That means it's -1. All right. I'm looking at number 2 right now. Well, you know what?
What's number 3?
Let's do number 2.
How about let's do number... Yeah.
All right. Tell me what you know before we graph it. A is 2. What does that mean? If A is 2, what does that mean? It's happy. It's positive. It opens up. What else do you know? B is 16. What else? C is 33. What does that tell us? Whoa, that's way high, right? So I might not be graphing the y-intercept this time, and that's okay. Y'all ready? All right, y'all told me A was 2, B was 16, and C was 33. Right? What's my first step? What do I do first? That little formula. I need the vertex because I need to know where to go. 2 up, 2 down, right?
So that's the worst part of this. So do you have to change it to a negative?
Yes, Shaija, that's exactly right. All right, the formula, remember I told you think opposite B, not negative B, over 2A. Not negative B, but think opposite B. So if B is negative, make it positive. If it's positive, make it negative. Do the opposite sign of B. Okay? All right, so look. B is 16, so it becomes -16 to A. A is 2 this time. All right, so -16, what is 2 times 2? Opposite B.
You have to change it.
Yes. Opposite sign of B. So my axis of symmetry is going to be off the axis now. It's going to be over at -4, right? So now they're not just going to be nice reflective points. They're not going to be the same. I'll have to actually calculate each one. That's fine, though. What it tells me is that when I do my t-chart, and I need how many points? 5. I need my vertex, and then I need 2 up, and I need 2 down, right? My hair's in my eyes. It's tragic. All right, so -4. The middle one being vertex. Okay. Now it's just a matter of plug and chug. Plug and chug.
I thought the 6 and 5 was supposed to go
Either way, it doesn't matter. You can.
Okay, so who's on the other X? What?
You don't need this anymore. You're done with it. So now I'm gonna I'm gonna plug in my X values for those X's for both of them. So 2, and then it's gonna be -2 squared plus 16 times 2 plus 33.
I'm gonna have a breakdown. I'm doing a breakdown, but before the end of the school year, you should get negative.
Oh, this is -2 right here. What'd you get? What'd y'all get?
I got -3.
4, 8 minus 32.
what I'm doing now. What you doing, Charlie? I'm having homework. No, you're not. Yes, I am. No, wait. Alright, watch.
It's so good. I think this is my number. Because they just have on mental break.
So where did the next? Oh, it's over in the background? Yeah, I had to fix them.
Let's do it. Let's do
I got
2 times -2 squared plus 16 times -2 plus 32. Oh.
And then we, what?
What is you doing,
And what are you doing?
What is it plus what? 33?
I didn't put 22 around the 16 top.
You have to do that to make sure it,
You most likely don't got that on that paper.
we'll make a note to do that.
Put all these answers into the calculator.
Huh?
Like the person who created the calculator.
Oh, yeah.
How long it took them to actually put all this stuff in.
Wait, how?
Alright, y'all do this. Y'all do this. Find the rest of them on your calculator and let's make sure, I need to make sure everybody can get this before I set you loose because this is the part that I don't want you to mess up on.
Okay, but you took 16 times 2. I got -6.
Yeah, in parentheses. Alright, I'm gonna graph these.
Mr. B, do we gotta graph these two? Exactly, that's why I'm
That's the whole point of this.
Mr. B. Okay, so.
That was great, Zai. Good job. Alright, -2, 9. -3, 3. -4. Oh, I set this up poorly. Let me do this again. I'm showing you. Hold on. I did. That's not the middle, though, Shais. You remember the middle, your axis of symmetry,
It's -4.
is here.
Oh, you saw, okay.
So what's going to happen is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. -2, hush, Zamoria. -2, 9. -3, 3. -4, 1. -5, 3. -6, 9. Yes. And look, it goes up forever, and as it's going up, it's inching outwards. It's a terrible connect the dots, but it's okay. That's why, notice, remember our y-intercept was 33? It's got to get all the way up to 33 before that parabola finally makes it over far enough to hit the y-axis. Okay?
2A.